Hello, Accelerated Math 7-8 students. We are working in Module 13, and this is going to be Lesson 5, and it's called Operations with Scientific Notation. Operations with Scientific Notation. Okay, here we go. Operations with Scientific Notation. Our goal for today. Today we will learn how to apply all 4 operations to scientific notation. So we've been working a lot with exponents and how they work. We've been learning about standard form. We've been learning about exponential form. We learned about scientific notation yesterday. And so now, today, that we understand what they mean, we're actually going to apply some math properties or math operations to them. So when you remember what a math operation is, we're talking about addition, subtraction, multiplication, and division. Okay, so that's what we're talking about with that. All right, when must your bases and exponents be the same in order to apply an operation? Okay, let me read that one again. When must your bases and exponents be the same in order to apply an operation? Now, I'm not going to tell you the answer to that right now because I want to see if you can figure it out with the stuff that I'm going to teach you today, but I want you to be keeping that in mind as we go through. So, things to know. Something that I want you to be thinking about is what happens when it is time to combine or separate scientific notations. So you're going to be given, remember, scientific notations are used because the numbers are either extremely large or they are extremely small. So the thing that I want you to be thinking about is there are times when you need to combine them, which means that we're adding them, right, or we're multiplying them, or it means that you need to separate them, and so that involves subtraction and division. So there are times when you're going to have to use scientific notation to do that, and there are some specific rules that you have to follow in order to do that. So there are specific things to remember. Let's talk about multiplication first. When you're multiplying two numbers that are written in scientific notation, you have to use the same rules as the laws of exponents, okay? And so what we're talking about is your bases have to be the same. If your bases are the same, then you just add the exponents. So I want you to think about that for a minute. Are all bases the same in scientific notation? The answer is yes, because they're all being multiplied by the base of 10. So your bases are already the same, so that's easy. So all we have to remember with scientific notation is that we have to add the exponents when we're multiplying, okay? Because remember, when you have same bases, you add the exponents. Okay, so that doesn't seem so hard. And then you just have to combine like terms. And we haven't combined like terms for a very long time, but I'm hoping, knock on wood, that you remember what that means when I say combine like terms. So the first thing we have to do is we have to identify all the terms, and then we have to identify the ones that are alike. And then we remember the rule that if the bases are the same, you add the exponents. Okay, so let's check this out and see if it's truly making sense. So our example is we have 1.5 times 10 to the 4th power times 3.4 times 10 to the 9th power. Okay, so the first thing we're going to do is we're going to identify the like terms. So in order to do that, I'm going to get some other colors so that I can show you this. In order to do that, we need to identify what we have. So we have a decimal, which I'm going to put a box around, okay? And we have a decimal, put a box around. So I would consider those like terms, okay? Because there's no basis there. They're both decimal numbers, so that makes them alike. However, these guys over here, I would say, are like terms with each other also. And the reason why I would say they are like terms is because they're both powers of 10. Okay, so that makes them alike. So basically, what you're going to do is you're going to combine the ones that are alike, and you're going to follow the rules to do that. Well, how do you multiply a decimal by a decimal? Well, that's very simple. You just multiply a decimal by a decimal. So we're going to take 1.5 times 3.4. You all know how to do that, yeah? Okay, and then we have to remember that we're multiplying those, and we're going to then multiply those by the power of 10 once we deal with the power of 10. So we have 10 to the power of 4 and 10 to to the power of 9, so all I have to do, if I remember my rules, is add the exponents because the bases are already the same. Well, that wasn't difficult. Okay, so now let's do the math. So it says 1.5 times 3.4. So I take 1.5 times 3.4, and I get 20, I get 6, I placeholder 0, I get 15, I get 4, add those all together, and I get 5, 10, 1, 2 decimal places. So there we go. Already in the leading digit form. Yes. Okay, so now I have 5.1. I don't have to write the 0 because the 0 is just a placeholder, has no actual value. So 5.1 times, and then I take my exponents and I add the exponents because the base is the same. So it would be 10 to the 13th power. And that's my answer. Okay, so now here's the test to see if we are correct. We have a handy dandy calculator, and so I'm going to do it both ways. So I have 1.5 times 3.4 equals 5.1. I was correct. Okay, and then you have 4 plus 9 is 13, which we already know. So now we're going to plug it in and see if it works. I'm actually going to use parentheses like the original problem says. So parentheses 1.5 times the power of that times, okay, 3.4 times the power of 10 to the 9th power, parentheses, and boom, what do we get? Aha, check it out, guys. Oh, you can't even see it, sorry. Got so excited. Okay, so I plugged in what we had originally, just this, without all the colors. Sorry, you didn't get to see it. I was so excited. Okay, but then look at what our answer came out to. It says 5.1 times 10 to the 13. And look what we got, 5.1 times 10 to the 13. So it works on a calculator, too. So we did it correctly. Nice job, everybody. All right, so now moving on to the next one. Division says use the same rules with the laws of exponents. So again, we're going to identify like terms, and then we're going to remember same basis, subtract the exponents. Okay, so going through and doing what we did. Here's the decimal. Here's the decimal. Here are my powers of 10. Here are my powers of 10. All right, and remembering this time that it's division. So another way we could write it is here, right? So we can either write it like that, or you will see it written like this, okay? So again, here's my decimal divided by a decimal, right? And then my base of 10 divided by a base of 10, yeah? And so we follow the rules. Okay, so it says 1.8 divided by 3.7. So I'm going to do the math. I have 1.8 divided by 3.7. That's what I'm going to do first. And then I'm taking that and I'm multiplying it by my base, which is 10 to the 4th divided by 10 to the 9th. Okay? All right, that doesn't seem so difficult. So now we do the math. Okay, this is not looking so lovely. But if I multiply both of these by 10, then I get 18 divided by 37, right? And we know that that won't work, so we have to put some decimals in there, or a decimal point. Again, we took it out to divide it, and now we put it back in. So now we have 1,800 divided by 37. So 37 can go into 18 maybe 5 times. So 5 times 7 is 35, regroup 3, so that's too much. So let's go 4 times. Okay, so 4 times 8 is 28. Regroup, that's 12, 13, 14. All right, so now we're subtracting. So that's 2, and that's 3. Bring down your 0. So 37 goes into 320. Let's say 8 times. So that's 56. 8 times 3 is 24, 25, 26, 27, 28, 29. That might be the closest. So let's try it. So 56, 24, 25, 26, 27, 28, 29. Subtract that out, and let's see what happens. So that becomes a 2. That becomes an 11. That becomes a 10. So we get 4 and 2. And then it looks like we're going to keep going for a while, right? So let me use a calculator because I'm tired. 18 divided by 37 gives me, oh yeah, it's a repeater. So this would be a 6 right here. So that's 2, 4 up here, that's 12, 13, 14, 15, 16. And we subtract those out. So that's going to be a 1, that's going that's going to be a 10, and that's an 8, and that's a 7, and then, yeah, so it's going to repeat each time. I think, let's see, 240, 37 times 6 equals, oh, wait, no, 222, sorry, that's my math. Good morning, Mrs. Nelson, wake up. So 8, oh, wait a minute. Okay, so this becomes a 3, and that's staying a 2. Okay, so 10 minus that is 8. 3 minus 2 is 1. There we go. Yeah. And then you do see how it's going to repeat because then that's 148. Okay, phew. All right, so we have a repeater. Bring your decimal point up here. A repeater. So now here's the thing that we didn't cover, but we're going to cover it in a minute. So this answer right here for this division is 0.486, and it repeats, so we'll put a repeating bar. And then if you divide this one, the bases are the same, so it would be times power of 10, but it's 4 minus 9. And so now we have an answer. If you look at it, we have 0.486 times 10 to the negative 5, and we can't leave it in a negative exponent, and we actually have to get, so there is a leading digit that is greater than 0. So we are going to actually divide this by 1 more 10, because we have to get the 4 as the leading digit. So when we do that, if you divide it by 10 one more time, you get 4.86 times 10 to the negative 6. Okay, and now let's see what that looks like on the calculator. Boys and girls, the calculator is definitely your friend in this module because you have to check your work. But here's the thing. You have to know how to do it without the calculator, so you have to be able to do it both ways. All right, so 1.84, let me put parentheses 1.8, times 10 to the 4th power, parentheses, divided by, parentheses, 3.7 times 10 to the 9th power equals that gigantic number. Look at it. Decimal point, count the zeros. 0.123454865. They rounded. Okay, so it's 5 zeros in front. So now let's see if we show this in standard form, what it's going to look like. So keep that number in mind. You should have 5 zeros before that because they rounded. Okay, so ready? We're going to try it now. So if you have 4.86 times 10 raised to the negative 6th power, what do you get? Count your zeros. 1, 2, 3, 4, 5. Ta-da! We found it. Okay, so we did it correctly right here. Okay, so I know that's a lot, but you take your decimals and you divide them. We found out that it's a repeater. We take our exponents and we subtract them. And then we realize that we have to have a leading digit of a number that is in between 1 and 9. So we had to divide 1 more 10. And when we divided by 1 more 10, we went from a negative 5 to a negative 6. And so this is the final scientific notation for this problem up here. Okay? Don't get overwhelmed. It's fun. All right. Addition says find the power of 10 that they have in common. So when you're adding scientific notation, you have to find a power of 10 they have in common. To do this, you must move the decimal point by dividing or multiplying, and the powers must be the same to add. So it's kind of like fractions when you have to have a common denominator. Well, when you're adding scientific notation, you have to have a common power of 10. All right, so this number right here, 3.3 times 10 to the 16th power, and then we have plus 5.7 times 10 to the 19th power. So the problem with this is the power of 10 to the 16th power. This is the power of 10 to the 19th power. So we've got to either get this up to 19 or we have to get this down to 16. So remember, if you're trying to bring a number down, then it means you're dividing by 10. And if you're trying to bring a number up, then you're multiplying by 10. So you have to make the preference in your mind. Do I like multiplying by a 10 or do I like dividing by a 10? That's what you have to keep in mind. So for me, if I know I have to get 3 more, so that means I could multiply 10 to the 16th power by 1,000, and then that would get me up to 19. Because look, if you look at your calculator again, your calculator is your friend. 10 raised to the 16th power times 1,000, what do you get? Ta-da! 10 to the 19th power. Do you see it? Because we multiplied it by 1,000, which is 3 more 10s, and so it gave us that much more. So for me, it's easier to multiply this by 1,000, but you have to remember our mathematical rule that we always use. What you do to one side, you have to do to the other. So if I multiply this one by 1,000, then I have to remember that I have to multiply this one by 1,000 because we're trying to get the powers of 10 the same. So we already know by doing this that this is now to the 19th power, but I also have to take 3.3 times 1,000, so I'm going to take 1,000 times 3.3, and I get 1, 2, 3, and 3. Okay, placeholder 0, 1, 2, 3, and 3. Add those together, and I get this, and it's 1 decimal point. So that's what my new number looks like. So I have 3,300.0 times 10 to the 19th, and now I'm adding these guys. So plus 5.7 times 10 to the 19th power. Well, now, because my bases are the same, they don't change, just like in fractions. Your common denominator doesn't change. So my answer is going to be times 10 to the 19th power. And then what I have to do is I have to add these two terms. And so the most important thing that you have to remember, don't forget your rules of adding decimals, you have to line up your decimals. So I have 3,300.0 plus 5.7, right? So that would be 7 decimal point 5,033, and so I have that. But my question to you is, thinking about all of our rules, because it's getting trickier and you have to remember all of your rules, can we leave this like this? Is this scientific notation? And if you're saying yes, then you need to rethink it, because in scientific notation, you have to have 1 leading digit. Right now, we have 4 leading digits. We cannot have 4 leading digits. So, again, remember, you have to go 3.3057, because 5 and 7 have values, so we can't leave them off. Okay, so now it has a leading digit, but what did we do? We multiplied it by, count them with me, 10, 100, 1,000. So we have to take 1,000 to this guy. So if you have 10 to the 19th, let's show it on the calculator, 10 to the 19th times 1,000, you get 10 to the 22nd. So we need to say times 10 to the 22nd. Okay? I know, it seems like a lot, and I want you to not panic. We'll get there. Okay? So, really quick, reviewing. You have to get so that your powers are the same, which we did, kind of like a common denominator. So you have to have a common power, which we did. In order to get to the 16, we multiplied it by 1,000. What you do to one side, you have to do to the other. So we did that. Then we added our decimals, which were here. Our power remains the same. And then we have this answer, which is not in scientific notation, so we have to multiply it by 1,000. And what you do to one side, you have to do to the other. And so that brings us to this final answer in scientific notation. Okay, so let's check the calculator and see what the calculator says. Again, calculator is your friend, so you always check your work with your calculator. So 3.3 times 10 to the 16th power, parentheses, plus, parentheses, 5.7 times 10 to the 19th power, parentheses, equal, and look what we get. Okay, just what we said. All right, so does everybody understand what it is that we are supposed to do? Okay, there you go. Nice job, everybody. All right, so moving on to the next one. Let's see, subtraction. Find a power of 10 that they have in common. So subtraction is very similar to addition. Find a power of 10 that they have in common. To do this, you will have to move the decimal point, and the powers must be the same to subtract. So again, we do the same process. This is to the power of 8. This is to the power of 7. I want to show you something that might also help you as a check is how would we write this in standard form? So remember, when you're multiplying by the 10, the decimal point moves the number of places the exponent says. So if we wrote this in standard form, then we would have 1, 2, 3, 4, 5, 6, 7, 8, 2. Why did I count them? Because that's the exponent of 8. So count the places. 1, 2, 3, 4, 5, 6, 7, 8. And then we had a leading digit of 2. So this number is this number in standard form. So now let's do this one. Ready? 1, 2, 3, 4, 5, 6. And it only goes to 7. So here's 7. And then the leading digit of 4. So that's that number, right? Count them again. 1, 2, 3, 4, 5, 6, 7, and the leading digit. And now it's telling us subtract. Okay, 0 minus 0, 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 0 minus 0. This becomes a 0, this becomes a 10, so that's an 8. We have to regroup again, so this now is a 10, which is a 6, that becomes a 1, and then we have this answer. Okay, that's not so hard. And can we turn that into scientific notation? Absolutely. The leading digit is 1. The next two have an actual value, so we can't lose them, times 10 to the, and the number is larger than 1, so we know it's going to be a positive exponent. So count them. 1, 2, 3, 4, 5, 6, 7, 8 times 10 to the 8th power. So that's the answer. So that's an easier way to do what we just did on the other side, but I needed you to see both ways, okay? So this is the fail-safe way. Turn them both into standard form and subtract, and then convert them into scientific notation. I have to be honest and tell you I like this way better. You can do it for addition the same way. You would turn them both into standard form and then add them together and get your answer that way. So it's kind of interesting that you can do it either way. Again, if you were to do it this way, your bases have to be the same. And so I would obviously multiply this one by 10. So now I have 2.1 times 10 to the 8th minus 42 times 10 to the 8th, right? And then we're subtracting, okay? And so you see how just by putting those two together, you can figure out which way it goes, and we go from there, all right? So I think for me, personally, I like doing it in standard form and then turning it into scientific notation, so you have to decide what you want to do. All right, so now let's take a look at these two practice problems. Please do not panic about all of this. I know it's a lot, and I don't want you to be overwhelmed, but I would like you to try these two. This one is adding. This one is subtracting. Do me a favor and convert them into standard form first, and then convert to scientific notation, because I think you'll have more success with that. Okay? All right, let's go back to review very quickly what our goal was for this lesson. Today we will learn how to apply all 4 operations, which we did, to scientific notation, and I don't expect you to have it down perfect yet. It takes time and it takes practice, and that's what we have in class. When must your bases and exponents be the same in order to apply an operation? You can now tell me that. Adding and subtracting is when the bases and exponents have to be the same. That's the only time is adding and subtracting. Otherwise, multiplying and dividing is easy because you just remember the rules. Find like terms. If you're multiplying, add the exponents. If you're dividing, you subtract the exponents. All right, my darlings, that's it. Very long one today, but hopefully it's going to make sense with more practice. Talk to you soon. Bye.